Hello everyone, welcome back to the another session in design and analysis of algorithms. This video is continuation part to the last video about optimal binary search tree. So this video will be going to cover how can I apply dynamic programming approach on optimal binary search tree. And also we'll cover taking an example and solving using dynamic programming approach, and we'll construct finally optimal binary search tree. So these are the topics, or these are the things what we are going to cover in this video. Now let's get started. So before of this video we were discussed about this example that I have taken 4 keys to find it out what is the cost of it, correct? So now the way how I proceeded is once I given with the number of keys and name of the keys, I started to found how many binary trees I'll get, the possible number of binary trees I'll get. For that also we were taken the formula in the previous example that 2ncn by n plus 1. With this formula we were found that 14 possible binary trees will get. If keys are into 5 proportional to the number, we will see the more number of binary trees. If it is 6, again you will have more number. If it is 7, again you will have more number. So for all these 14 trees, you cannot find out the cost. And this cost, what I have taken this formula, this cost is for existing binary search tree. That when you given with keys and when you given with a tree, then this is the formula to calculate what is the cost of binary search tree. But now this video will be going to take only the keys and the probability of successful search and unsuccessful search. We'll take only these things and we'll construct the optimal binary search tree. Find the difference. If you have a tree, then you can calculate the cost of it. If I don't have a tree, then also I'll have a formula, because keeping in mind that our element of the key. Now look at this example. This is 1 and this is 2, this is 3. Now here root element is 20, right? And so I'm just assuming k is key element. Now here key element is, here k value is what? 2. Let's suppose 1, 2, 3, 4. Now the root element is what? 2 element. Second key element was at root position. Now the same root element in one tree that was appeared at left child of other tree, correct? And if the same, if you can see here also that 20 is here. So point is what? In every tree root element will get change. For every tree cost will be differ. For this tree we got 2.1, and it is not at all sure that you will get the same 2.1 over here and you will get the same 2.1 over here. For sure it will be not 2.1, not 2.1. So the point is, for every tree you have to calculate the cost of it, and you have to find out the minimum cost which is producing, the binary tree which is producing. So this is what actually our task. But the very big problem is you cannot consider all the 14 trees to draw and to find out the cost. So that is the reason we'll apply dynamic programming approach on this problem. So as far as dynamic programming methodology or approach is considered, we'll take all these 14 combinations, all these 14 possibilities, not direct way, but indirect way we'll take. And we'll see that for which k element you will get the minimum cost. Right? Now we'll take an example and we'll move. So this problem is, I did not have any tree. I have only the keys. I don't have any tree as I have in the last example. This example I just given with. Now that is the reason I once again remind you the definition of optimal binary search tree. The definition is what? A problem OBST, optimal binary search tree, is that if the key is given, yes, we'll have keys. If the key is given and the probabilities P and Q is given, we have to generate a binary search tree. Who has to generate? We has to generate. So to generate the binary search tree, you have a formula. So according to this formula, we'll calculate for all the possibilities, and whichever is minimum, that it will be taken. Now you have to calculate the cost, and also there is a term which is W. W refers to weight of your I comma j. Let's suppose that also we'll see in the next slide. Let me finish this cost. So cost can be calculated using of this formula. Now let's focus at the formula is what? Minimum of 1 I less than k less than or equal to j. C of I comma k minus 1 plus C of k comma j plus wi comma j. Now the mean of this is we will be going to compare cost of 2. The 2 is what? Let's suppose that my k value is 1. My key value is 1. So now among my 4 keys, I have chosen the first key should be at the root position, that k is equal to 1. So my first element is in the root position. Then we will be finding out the cost in between of the first element, that the before element and the present element. Okay. Now whichever is minimum, that will be calculated with this wi comma j. We'll take an example and we'll move little more further. I wanted to calculate C cost of 0 comma 3. Now what k values are possible here? K, when you took 3 nodes, now 3 nodes, k is equal to 1, k is equal to 2, k is equal to 3. For these 3 possibilities, you have to check the cost. That's what C 0 comma 0. That means this is my k is equal to 1. So when k is equal to 1, my I value is 0 over here. It is I and this is j. According to the formula, this is what I comma k minus 1. I is what? 0. K minus 1. My k value is 1. 1 minus 1, 0. It is what? C of 0 comma 0. Now, plus C of 1 comma 3. What is this 1? K value. 3 is what? J value. So, this is what? The cost when my key, first key is in the root position. And this is what? C of 0 comma 1, C of 2 comma 3, this is what k is equal to 2, and this is what k is equal to 3. For all the possibilities of k, will be calculating the cost. Whichever cost is minimum among these 3, that will be considered. Right? Now, the other point is what? If you can see this one, again, we do have C 2 comma 3. If I wanted to get C 0 comma 3, I have to know what is C 3 comma 3, the upper value. I am at 0 comma 3. I have to calculate 1 comma 3 if I wanted to get 0 comma 3. Yes, I am at 0 comma 3. But in 0 comma, to get the value of this, I should know 1 comma 3 value, the next value. I should know 2 comma 3 value. I should know 3 comma 3 value. So what we are going to do is, we will do the reverse process. That will calculate the higher terms first. When you get these terms, these costs first, it will be very easy for us to get the lower values. Yes? Now, that's the reason we are just making our methodology little more simpler, that is these formulas. Look at this. J minus, we are calculating Ci comma j. When we are supposed to calculate Ci comma j, there are terms which are producing the bigger values, right? So that's the reason I'm just making formula very simplified. That is, when j minus I is equal to 0, that the j minus I is equal to 0 is what? When j minus I will become 0, for these cases j minus I will become 0. Keeping in mind this is I and this is j. J minus I 0. J minus I 0. j minus I 0, j minus I 0. For all j minus I values, we'll calculate first. The cost of these will get evaluated first. Then we'll come down for whose values j minus I is equal to 1. For that values we'll calculate. Now, the last you will be calculating C of 0, 3. When you calculate this, all the terms which are higher to that are evaluated first. So it is easy for us to get the value of this. So that is the reason why we segregated according to this logic, right? Now, so this is about cost. Cost of 4 keys depending upon k possibilities. Our k value lies from 0 to 4 or 1 to 3. Now, we should know weight because cost is included with wi comma j. So you have to know what is wi comma j. Now, so wi comma j formula is what? W of I comma j, wi comma j minus 1 plus pj plus qj. When you wanted to know the weight of one node or one key, you should even add the probability of successful and unsuccessful. Then you will be come to know what is the weight of the particular key. Now let's suppose what is the weight of 0 0 w00. It is 0 itself. w1 comma 1. w1 comma 1 also 0. Why it is 0? Look at the formula. Now I'm just elaborating the formula. What is I? 1. 1 comma. What is j minus 1? J minus 1. 1 minus 1 is 0 plus pj plus qj. What is pj? Pj is probability. Now we will be given with, that's what I have given the definition of OBST in the last slide. OBST example is what? We will be given with keys and the probabilities. Then only it is possible for us to generate optimal binary search tree such that the cost will be the minimum. Fine. Now according to this we'll bit move. Now this is the problem. This problem I have taken from the textbook. So this is the table where I wanted to find out actually the last cell value, which is W04. When I wanted to get this value, all the upper values are required for me in the equation. So we are coming to calculate from j minus I to further. Okay. Now, initially, we'll take W00 values. First of all, let's fill all W values, weight of your keys. Let's fill. You know already the formula in the previous slide. What is the formula to calculate weight? Wi comma j is equal to Wi comma j minus 1 plus pj plus qj. Now I wanted to calculate W00. Okay. Now what is W00? So W00 is what? You don't have any p value. Correct? Because now look at. What is P? Successful nodes. What is Q? Unsuccessful nodes. P value is what? Always it is equal to number of keys. Pi value is always equal to number of keys. Q value is n plus 1. And that's what you could able to see the probability 1 is extra. So let's name this one for the understanding purpose. So there won't be any P0. P1, P2, P3, P4. It will be equivalent to your nodes. It is what Q0, Q1, Q2, Q3, Q4. Only Q0 is extra. Right? Now, so W00 value is what? It is 0. W11 value is, you can calculate W11. What is W11 value? I is 1, J minus 1. 1 minus 1 is 0. W10 plus Pj. What is Pj value? I am calculating I comma, we are at j minus I, W0 comma, let's finish first of all this first row. So to finish first row, I am just calculating W0 comma 0. It is what exactly of Q0. Q0 value is what? q naught value is 2. So it is 2. And w 0 comma 0, later it is w11. W11 value is what? q1 value. So now let's suppose q1 is what from the given inputs? q1 is 3. Now keep 3 and w 2 comma 2. So all q values you can substitute over here. 2, 3, 1, 1, 1. So first weight done. Now calculate what? W 0 comma 1, weight of 0 comma 1. So what is what is w 0 comma 1? W 0 comma 1 is w 0 comma 0 plus p1 plus q1 j. pj qj means j value is 1, so p1 q1. What is w 0 0 2? W 0 0 is 2. Now substitute 2. P1 is what? P1, it is 3. P1 is 3. Substitute 3. What is Q1? Q1 is 3. Keep 3. And 3 plus 3 is what? 6 plus 2 is what? 8. So W01 value is 8. Okay. Now, so again you have to calculate what? I'll make the page little bit fresh so that you can understand what I'm explaining. Now calculate W02. What is W02? W0 comma 1 plus P2 Q2. P2 plus Q2. So what is W01? These values are what? 2, 3, 1, 1, 1. And this value is 8. So W01 value is 8 from this. What is P2? P2 is what? It is P1, it is P2. P2 is 3. What is Q2? It is Q0, Q1, Q2, Q3. Q3 is 1. So that is value is 12. So now you can write value as W01. W01 is 8. So P2 and Q2 is what? It is P1, P2, P3, P4. P2, Q2, P2 is 3 itself. Q2 is W02, it is here 12. Right. Now again you have to calculate W03. W03, apply the same formula, you will get 14 and 16. W12, apply the same formula, you will get the values. I'm just filling it, but please don't blindly copy it. You have to calculate the values as the way I am calculating over here. So if you calculate these values, you will get W23 as 3, W34 as 3, W13 as 9, W24 as 5, W14 as 11. These are the values. Now you have to calculate the cost of it. So what is the cost formula? Just now we were seen in the last slide. C of ij is equal to, you have to take minimum of C of I comma k minus 1 plus C of k comma j plus added weight W of I comma j. So now you have to calculate cost, for which you have to calculate, let us come from the first row onwards, C00. So C00, it is 0 itself, because if you try to calculate C00, k value, we don't know what is k value, as k value starts from 1. Correct? So that's what initially cost is 0. Initial values. As your k starts from 0, you cannot find who is the root, because there is no possibility that k starts at 0. So these values are also 0. Now start from this j minus I is equal to 1. That first possibility is what? Your k value is 1. Keeping in mind that k is equal to 1. Okay. So C01, we'll just make this fresh. Now I'm calculating cost of 0 comma 1. So 0 comma 1, I have possibility k is equal to 1. Okay. Now when k is equal to 1, because why k is equal to 1? You have only one key. When you have one key, you cannot fix it for k is equal to 2, right? It is only having one key. Now k is equal to 1, that will be the root. K will be the root. Now that is C0 comma 0 plus C1 comma 1 plus W0 comma 1. Now so C0 comma 0 is 0 plus C1 comma 1 is what? It is also 0 in the previous example. For that is the reason you need these values to know. 2, 3, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. So C11 is 0. So I wrote C11 is 0 and plus W11. W01. W01. W01 is what? 8. W01, 8. W02. These values just now we got from the previous slide. You just remember that values so that it will be more easy for you to understand. So 0 plus 0, 0 is the minimum and 8. So finally cost of 01 is what? 8. Now right here cost of 01 is 8. And the same way you have to calculate cost of 02. Now here for all the values, if you calculate cost of 02, then that the figure will be what? It is again for 0 where we are C12. For C12 again you will get C1 comma 1, correct? C12 because it is k minus 1, your k value is starts with 1 and the possibility also 2. So finally it will be C1 comma 1. C1 comma 1 value is 0. Here also for 2, 3, 2, 2 value it comes. For 2, 2 is 0. So anyhow one term is becoming 0. The other term also it becomes 0. So whatever weight you got in the previous, that the weight will come for second row also. That W12 is 7, W23 is 3, W34 is 3. Now the same values will be comes in cost. You can check. You just write the formula and you will be calculating it as I calculated for the first time. First term. For second term, you will get 7. For third term, you will get 3. For fourth term, you will get 3. Okay. Now, for whose values this cost is 8, 7, 3, 3. When k is equal to 1, you got the cost is 8. When k is equal to 2, you got cost is 7. When k is equal to 3, you got cost is 3. When k is equal to 4, you got cost is 3. So for which k you got these, that is what your root value. Now you have to calculate the cost of for remaining also. For CO2, now we will calculate for CO2. That means we will calculate for this row. This row means what? Cost of 0 comma 2. Cost of 02, cost of 013, cost of 24. This we will calculate. For cost of 02, I am calculating. I am just calculating for single, for one value in the row. My sincere advice to all the students, please do calculate. Don't feel it is burden to calculate. Calculate so that your hands will get some experience or practice to find in the exam. Now, you have what? 2 keys. When you have 2 keys, you have to change k value. First you have to take 1, the next you have to take 2 because you have 2 keys, right? So, right. Now I'm starting with k is equal to 1. When my k value is 1, your formula is C0 comma 0 plus C1 comma 2. It is my k value 1. For k value 2, C0 comma 1 plus C2 comma 2. Now, W0 comma 2. So, you should know which among it is minimum. Now, again, minimum of what is C00? C00 value is 0. C12 value is 7. And C01 value is 8. C22 value is 0 and plus 12. So 0 plus 7, 8 plus 0, which is minimum. 7 is the minimum. So 7 plus 12 is equal to 9. So here, by making which k value you got minimum as 7, this is what? K is equal to 1. So when k is equal to 1, you got minimum value. That's what you have to write here 1. because it k value for whose root value you got minimum value, that value you have to copy, and cost is 9. So likewise you should calculate for C13 and you should check for whose R value. You should check for C24, for R24. Okay, and for next case is j minus I equal to 3. For this also you have to calculate. Now 3, right? 3 in the sense what? Keys will be 3, 1, 2, 3. So one more row will get added. Among these 3, whichever is minimum, that value you have to write over here. When I is equal to 4, you will have keys or 4. So you should write 4. Among these 4, whichever is minimum, that you have to write. So finally, these are the values. Finally, these are the values of weight, cost, and particular root key. So taking these values into consideration, we'll be going to calculate, we'll be going to construct the binary search tree. Now let's see. For these values, we'll be going to construct the binary search tree. Now, so your for which value? Finally, you got which value? Final value is 2. Root is 2. That means you should take root value as 2. So root value as 2 in the sense what? You given with the 4 keys, right? You given with the 4 keys, and the final key is what? Final key is k is equal to 2. For k, when k value is 2, means k is equal to 2. That means key value is in second position, which is 20. When 20 is the root node, you can see the minimum cost. When 20 is in the root position, then you can see the minimum cost. Okay. Now, what is, how to draw the binary search tree for this? Now, I am just dividing it for left and right. Here it is k value is 2. Now, what will be the positions of this side? That means the possibility of this side is 0, 1. The possibilities of this side is 2, 4 because I have 4 keys, right? Now, what is the value of R0, 1? R0, 1. R0, 1. It is 1. R0, 1. 1 is what? K value. K is 1. In one position, which key is there? 10 is there. So, it should be 10. Now, right position value is what? R2, 4. What is R2, 4? 3. R2, 4 is 3. So, key value is 3. Who is there in the third position? 30. Now, come for 30. Now, again, divide it. So, it is what? Anyhow, you have one element. That element you can place over here. If you don't have one element, the way how you have to think is, it is R3, 4. Correct? So, R3, 4 value is 4th key. That's what your 40 has been placed over here. So, among 14 binary search trees of 4 keys, this is the binary search tree. Optimal binary search tree. For whose tree whose tree cost among 14 is minimum. So, what is this minimum? Minimum is what? 32. The cost of the tree is what? 32. And very interesting point is what? The probabilities always has to be 1 actually. Successful probability, unsuccessful probability. But we were given with some decimal points over here. Working with this points, 0.2, 0.3, it may be typical. That's what we were taken this number, numericals. But there is a logic behind of it. If you sum all this, you'll get 16. Okay. If you sum all this P plus Q values, you'll get 16 as your answer. The cost, whatever I got, this is 32. If I divide with 16, answer is 2. So, 2 is the original minimum cost of my binary search tree. Did you understand? Now, this is what the problem of optimal binary search tree. I have taken sequence of decisions. In each stage, I took a decision for whose root value I got minimum cost. For whose root value I got minimum cost. So likewise, I got this. Okay, right. Thank you all.